Welcome everyone. My name is Ricardo, and I have been working on Guix for a couple of years already. Wow. This is going to be a gentle introduction to functional package management, which means that I'm not going to define what functional package management is. Instead, I'm going to start with a bold claim. Package managers are really useful. Who disagrees with this? No, package managers are really useful. This is a meme in computing. It's been around for a while, and there are different variations of it, but it has survived so far. But they can be so frustrating. Right? Who has never had a problem with packages before? Installing software and... Oh, good. Well, then I actually could skip all those slides, but for the benefit of the people who are watching from afar, these are just off the top of my head a couple of issues that I've personally encountered and that probably have shortened my lifetime. So the first thing that you will encounter when things go wrong is version conflicts. So you may want to have a particular version of a piece of software and it's not available, and you can't really just install that version that you want because that would conflict with what is already there. This leads us directly to the other problem, which is that usually old software is available. Because harmonizing all these dependencies between different packages takes a while, and it's non-trivial. So as the dust settles, actually the software world has already moved on. So we're always a few steps behind. Upgrades can be very suspenseful, which is why in the past I would not touch my computer before giving talks or before deadlines, or I would actually really just try not to upgrade because I want to use the computer. Because the only way is forward. You can't really go back. Once you committed to an upgrade, it's really hard to downgrade in traditional systems, or those systems that I've encountered anyway. And it gets worse, well, twice as bad when it's not just you using the machine, but if it's a shared machine. Like you have a computer at home, and it's you and your kids using the machine, and they upgrade because they have root. They shouldn't, but so they upgrade the machine, and then you can't submit your paper because you're a serious person who writes papers. And that's bad because, as we established already, the only way is forward. You've got to kind of arrange yourself with it, like switch jobs or become an artist. And trust. Trust is an issue. How can we be sure that the software that we install on our machines is actually the software that we want to have installed? This is a really hard problem, and a lot of people are working on this. There's a whole community of people who work on reproducible builds that give us the tools to at least challenge trust issues, so that we cannot be sure that we can fully trust things, but at least we gain some confidence in that the software we are running is actually the software that corresponds to the sources that we've read. But there are a couple of partial solutions or attempts at solving things, and these are just a few that I've encountered so far. The first one is obviously you just don't use package management. You have a compiler and you know how to use it. If you don't, then that is a problem. This is not a solution for you. And it doesn't only extend to the package itself, but it may extend to packages that are different versions recursively, right? Dependencies for that package that's at a different version than the one that's provided by public repositories. So you might just rely on other people doing that work for you by using external repositories that provide pre-built binaries. So in enterprise environments, people often use this Apple repository. On Ubuntu, it's popular to install and enable PPAs, where you can just download packages that other people have built. There's a user repository for Arch, GNU plus Linux, and usually the problem that they solve comes, or the solution comes with a host of other problems. You may have not the original conflict that you started with, but you may have additional conflicts in trying to harmonize these different repositories, the official one and the external one. And there's even more software that you have to trust, and where you may not actually have the tools to establish trust. Another common approach to solve the problem is to use application-specific package managers. It seems like every language has its own package manager, and if you have a non-trivial piece of software that is written in Ruby and Haskell, and maybe a sprinkling of Python, and then you may have to use gem and cabal and pip. It's not just one tool you have to learn, like your system package manager, but gem and cabal and pip, and they all behave slightly differently. They all have their idiosyncrasies. So it's more packages, but less management. And you're just devolving this to a language level, which is just a little bit better than doing it on a per package level. You could also build your own system packages. If you're using apps, you could write a Debian package. And who does this on a regular basis? Who enjoys doing this? Or you could use RPM. This is kind of hard to do because, again, you've got the same problems as with using no package management at all. You've got to solve all these issues first, but you're rewarded with a binary that eventually breaks as the rest of the system moves on. You've got to rebuild things again. You can also automate that, right? You can generate RPMs and you can generate Debian packages with things like FPM. But I don't know, maybe it's just me, but I feel this is really inelegant because it generates so much boilerplate stuff just so that you can install software. It doesn't adhere to any particular standards. It's weird, right? I used it before because I wanted to distribute software to people who may only have, who may be using Debian, and people who use RPM-based systems. So I wrote an FPM package and built all these binary archives that people can install. So this helps a little bit for lazy distribution of software, but it doesn't really help users themselves. A very popular solution nowadays is to just give up and say, packaging is really hard, so let's not do it. Let's just shrink wrap the whole environment and distribute that binary blob to other people who can then run that thing. Introducing functional packaging. Functional here does not mean it works. So it does work, but that's not the meaning of the term here. A functional means just like a function, like a pure mathematical function. So that's like a metaphor. So this is the function here. I see you can actually not read the top. This doesn't matter, right? So you treat the build process, the build process as a function that has inputs and produces some output. Inputs for a package build process would be the header files, the sources, all the tools that you need to build something, all the libraries that you would need to link the software with. And out comes some binary artifact, a tree of files. In this case it's Emacs. Which generates a couple of libraries and a couple of binaries that you can run. Now, one thing that I would like to stress here is that with functional packaging, the target directory includes a hash of all the inputs, which means that if you change one input, and it doesn't matter which one and how far up the graph it goes, you will get a different output directory, which means that installing or building Emacs with this version of GCC is going to yield one output, whereas building Emacs with that other version of GCC will yield a different output. So you can have different variants of a piece of software, and it is not just dependent on the version. Right? So it's not just I want to use Emacs 25.1 and I would also like to have Emacs 24 something. No, you can have different variants of Emacs 25.1 if you wanted to, and all of the inputs are encoded in that hash, and so it gives us a unique new namespace to which we can install things. So same inputs mean you get the same output, ideally. And with different inputs, you get different outputs. The way this is done in Guix is that we've got this Guix client, this command line tool that a user, an unprivileged user, can run. That Guix client talks to a daemon, it runs as root, and performs things on behalf of the user. The things that it performs is the abstraction is that it spawns isolated build process, isolated environments. It fashions isolated environments that give a new view on the system, where only declared inputs are available. That means if I were to tell Guix to build Emacs, and I didn't say that I want to have a compiler available, then that build would obviously fail. Yeah. So I have to say I want to have a compiler, and I want to have this and that, and a linker and whatever, and the daemon will comply and create an isolated build environment where that compiler that I specified is available. All the libraries that I want to have are available. All the other packages things depend on are available. And eventually, the build artifacts are in a store. In the store,
sorry.
Everything eventually ends up in the store in its own namespace, in its own prefix directory. But these prefix directories, they're really, really long, right? They're ugly. There's something like /gnu/store, a really, really long hash, minus the package name, the version number, and then you've got /bin or /lib or whatever. Nobody in their right mind would like to memorize all these hashes so that they can use Emacs. Right? This doesn't happen. So to simplify all of this, there's the notion of profiles. You can't see this up there, but this is my profile. It reads as /home username.geeks profile, and this is really just a link. It's a link that points to the current Geeks profile, somewhere in a state directory, which points to the current version of the profile, which again is a link into the store, to the actual profile, which again contains links. It's a union of all the things that should be in my profile. So in this case, we've got a profile with an ugly hash in front of it, and it contains two tools, SemTools and Bowtie. But these are just links to the actual tools. Right? So in the store, we've previously built SemTools. So my profile just references SemTools in the store. It also references Bowtie, which is in a different output directory. So profiles are unions of all those individual trees with their prefixes stripped. And the current version is really just a link to the current version. Right? So if I were to remove a piece of software, I'm not going to modify anything in there because the store is immutable. Instead, what I would do is create a new generation of my profile. Now it's generation 43, which points to a new profile, which no longer contains the package that I removed. But if I wanted to, I could just go back, right? I could just change the Guix profile link to 42 again. Go back and forth and back and forth and back and forth. Nothing ever changes really. So the store only grows. Until I decide to delete that link, the 42 link, which then shows us that the profile itself is no longer referenced by anything. So I can run the garbage collector and collect that unused profile. So before I move on to something funny, I'd like to demonstrate this. Can you see this? Or maybe like this. Okay. I'd like to greet you, but I can't because I don't have the hello command. So as an unprivileged user, I install the hello command. And it tells me that it will install hello 2.10. I guess it says hello in a fancier fashion, but I don't know. And it installs that somewhere into the store. So there's a /GNU/store, a long hash that is elided here. Hello something something. We can take a look at this. Inside that there is a bin directory and a share directory. So this is a real tree, right? What you would normally have at the root. And now I can greet you. Greetings. But this is kind of artificial. I never had to install hello before, except for demos like this. So let's install Python. So it tells me that Python will be installed somewhere into the store, and it also tries to be helpful and tell me what I may have to do in order to use it. But I don't because so here it is. But I realize I'm in the Guile dev room, so I shouldn't be using Python. So let's remove this and use Guile instead. As you can see, this is a transaction. I'm doing this at once. Right? I'm removing Python and installing Guile in the same transaction. And now Python is gone. Right? And there's Guile. Now this is what happened. When I installed hello for the first time, that created a profile, generation 1. When I then installed Python into my profile, it added Python. That means it created a new generation that included Python. The previous generation is still available, right? It's still there, it's unmodified. I could go back to that. Generation 3, where I've removed Python and installed Guile. So what's currently installed is this, right? Hello and Guile. If for some reason I want to go back and undo a mistake, which it was no mistake here, but this is just for demonstration purposes. I'm going to switch back again. So here you see that generation 2 is now the current generation. And now if I want to use Python again, for whatever reason, it's there again. And Guile is gone. I'm not going to show that though. So, rollbacks. The feature of having generations and appending only to the store gives us rollbacks just by changing a symlink. Right? That's beautiful. We can also install software into different separate profiles. So we could use one version of Emacs and compare it with another one if you wanted to. Or in a scientific environment, you could install a whole workflow into one profile, and for a different project, you have a different workflow. And you can use both of them. So this is beautiful. This is all completely isolated. Right? My changes here will not affect any other user. They won't have to use Python if I make the decision to use Python. If I install it into my profile, it will really only affect me. So the way that this works is by using Scheme. Right? So the Guile is written in Scheme. Guix is written in Guile, which is an implementation of Scheme. This may look confusing at first, but let me show you first what a couple of things about Scheme. Okay, so these nail clippings, they're important. Everything is a parenthetical expression. And the first thing in there is special. Okay? Everything that follows is just arguments to the first thing. This is a simplification, okay? But in general, this rule applies. Whatever is first is kind of special. It may be a function, it may be special syntax. So in this case, we have a list, so an expression, an S expression that has 3 elements. The first one is the function plus. The other 2 are arguments to that function. Now what I can do is I can quote expressions. Right, so that evaluates to the list that contains 3 elements. And you can think of this as a toggle switch. Right? So right now it points upwards, which means code mode. Data mode. So all of this, what follows, is now data. It's not going to be evaluated, but you can flip the switch down and enter code mode, where things are evaluated. Okay? And now this no longer looks that scary, I think. So maybe that was too optimistic. No. So we are defining a name. I say that this name, GLPK, is whatever follows evaluates to. This is a package that has a name, obviously, and it has a version, and it has sources. We don't care so much about this right now. Let's get to the build system. The build system is the GNU build system. Configure, make and store. Oh, that's too bad. And here you see the toggle switch, right? So we've got inputs, and that is an actual package. There's a package just like that.
Okay, we have time for questions. And
Yeah.
Can we ask the next speaker, John, to set up?
Yeah, questions. If you want to learn more about Guile, just come to me afterwards.
I'm quite familiar with Nix. What's the link with Guix? Is Guix 4 or no link at all?
I was waiting for this question. The question is, what's the difference between Nix and Guix? Is that fair?
I'm quite aware what's the link?
So both
community intersection, code intersection?
Both Nix and Guix are implementations of the same principles. Right? Both of them are functional package managers. Nix is older than Guix, but Guix is a different implementation that uses Scheme throughout, which has wide implications on a lot of things, actually. This would deserve another talk. So there's a lot of differences that come from that initial design decision to use Scheme. So Guix uses the Nix daemon underneath. So and the derivations that it uses are the same. So the same format. So I think in principle they are compatible. But everything above that, everything that's not low level like this, is very much different. Okay, do we have time for another one? Sure. Yeah.
You have similar as NixOS, where you have a
yes.
configuration.
Yes. is there something similar like NixOS? People may not know what NixOS is. That's a distribution, a GNU distribution that builds on Nix. And yeah, for Guix we have this too. It's running on this machine actually. It's called Guix SD, and it extends the ideas of Guix to the operating system level, and it has declarative configuration of the whole operating system. Also in Scheme, so it's same kind of thing.
Is there anything to delete generations when you run out of disk space?
Is there a way to delete generations? Yes. You delete the link, so there's a command line thing for deleting older profile generations, and then you run the garbage collector. Yes.
How do you deal with security updates? And who is
Security updates are handled by what's called grafts, which is an optimization. But to actually explain how this works in detail, I'd rather not do it right now because that would take a little too long. But we can. It's documented, and you can find it on in the manual, which is really extensive, or we can chat later.
Yeah, I would like to chat.
Okay, cool. That's it. Thank you.